Okay, back again. Sorry about that. Let's ignore that real quick. Let's create a T-chart to help us out. So we have an X and Y values. Now, to help me graph this function, what I'll do is, let's pick a X value on one side of my vertex and X value on the other side of my vertex. Because we know a vertex splits my V shape directly in half. So I know what I get on one side, reflect over the other, so on and so forth, keep plotting, and we're good to go. So let's start 1 over from where our vertex is. Let's try an X value of -1. If I were to plug in -1 here, I get 2 times -1 plus 2. -1 plus 2 is 1. That's 2 times 1 on the inside of my absolute value. Now I subtract 3, that's 2 minus 3, which gives me -1. So now I have the point -1, -1. Well, that's up here. So we know that my vertex is here. Reflect across that line. I'm here. Now we just draw that out. I'm a little bit without a ruler here, so I apologize for the crookedness of the lines, but you guys get the idea. I go up 2 over 1, up 2 over 1, up 2 over 1 on each side. Okay? Now let's think about the domain and range. Domain here, well, my end behavior on this side is it keeps on going that way negatively. It doesn't reach a stopping point at all. And on the positive side, on the other side of my vertex, it keeps on going in this direction. It doesn't stop at all over here. So my domain is all real numbers. My range, well, we have a minimum here, so I have to think of the fact that I hit rock bottom. My range must be all the Y values greater than that. That Y value right here was -3. And we're good. Okay? Next one. This one's a quick and easy one. These double brackets mean step function, right? So let's create a step function. But we have a -1 here on the inside of my double brackets. So that means I need to go to the right one. And we draw that out. The domain here is all real numbers. And the range, notice I have this split like we talked about earlier. So I'm only hitting the whole numbers, or my integers. So the range is all integers in this case. Okay? And that's really all you had to do. I didn't really expect a whole lot, and I don't think any of the other teachers expect a whole lot from that. As long as we can see that you moved right one with your start point, we're good. Okay. Next one. Number 9, we have the cube root of x minus 4 minus 1. So we think of our cube root function, looks something like that. And we take that vertex and go right 1, because we have minus 4 on the inside, and minus 1 here means we go down 1. Right, 1, 2, 3, 4, down 1. There we go. From there, we think about all the points, those critical points that we talked about in that table of values. We just draw out that graph. We had a point up 1 over 1 there, down 1 there. You can go down 2 this way, left 1, 2, 3, 4, 5, 6, 7, 8. And from there, we just connect the dots. And there we go. Not the prettiest looking graph, but domain, all real numbers again. Range, also all real numbers. No stopping points. We don't have a halt. This is a cube root, not a square root. Okay? Vertex does not indicate where we stop. Let's slide over. So this one we have a similar issue that we had up here. We have a number multiplied on the inside. So what we need to do is factor that out. 4 and 12 have 4 in common. That becomes the square root of 4 times x plus 3. We know that we need to move left 3. 1, 2, 3. And then draw a square root graph. But wait, hold on a sec. What's going on with this 4? If we can think about what's the square root of 4 times x plus 3, remember our radical rules. We can simplify this radical. That's 2 and 2 right there. Let's pull this out. Now what we have is a vertical stretch of 2. So my actual graph is going to go with each one getting stretched up by 2 with my y values. So my final graph looks like that. Again, I moved left 3 because I was able to factor out a number here. So my domain must be all of the x values after that 3. And my y values must be all the y values above that. Again, I would use your memory of what the graph looks like to know that we don't sweep down here or don't flip over that way because we have no reflections going on. All right, and then you're good there. Let's go ahead and flip over to the next page. Okay, this is a quadratic, big time review here. This goes back a couple units, but that's why we said to go ahead and start reviewing some of this, especially with what we threw on the piecewise homework.
And the benchmark coming up. Don't forget the benchmark.
Absolutely. Benchmark coming up on Tuesday. You guys are going to need to know all this. Remember, benchmarks are cumulative. Okay? So, let's think about what's going on. We have some kind of factor here, making it narrower or wider. This one's going to make it not wider because we have a 1/2. But before we get to there, let's go ahead and move our vertex with this +2 and -3. Go left 2, because of that +2, opposite of h, and down 3. Now, normally if we think about a quadratic, we would go up 1 over 1, right 2, up 4, so on and so forth. But to make it a little bit clearer, we can make our t-chart to clarify. First, we know that this is our vertex, so let's plug in -1. Or before we do that, we know that's going to get cut in half. So let's plug in all the ways over here. Let's go 2 spaces away just to see what we get. So if I go 2 spaces away all the ways to 0, we'll plug that in. 1/2 times 0 plus 2 squared minus 3. Well, 0 plus 2 is 2. 2 squared is 4. 1/2 times 4 minus 3 is 2 minus 3, which is -1. So let's plot -1 over here. There we go. You have a point, a point. Remember, axis of symmetry, you can start reflecting that over, and now you're already almost there. Let's just be a little bit more precise, maybe get one more point. And I think we're good there. Try to draw this out a little bit more accurately. All right. Domain. Again, all real numbers. We don't have any gaps, and we're not skipping spaces. The range, we have a minimum point. Review of parabolas. Our minimum was at the vertex. So we have to think that our range, all the possible y values, have to be above that minimum, -3. Okay? Go ahead and make sure you review this stuff back from quadratics. If you need to pick up binders or check some answers with some old notes, let me know, okay? All right. This is the tricky one for a lot of you guys. Inverse variation. So, what we need to think about here, oh, hold on, technical difficulties. Okay, what we need to think about here is where are my asymptotes, what's going to be going on, what's this 4 doing in the numerator, and how is that going to affect my corner points and where my asymptote is located at. First and foremost, let's find that intersection where my asymptotes are located. We know we have the point x is equal to h and y is equal to k, these being my vertical and horizontal asymptotes. X must be equal to -2, opposite of h, and k must be -1. Plot that out, -2. And we have -1. There we go. Vertical and horizontal asymptotes. Now normally we would think of our corner points being the guys right next to them. But we have this 4 here that's going to stretch that out. So instead of going just one space away, let's count 4. All right. Now we can also think of, to find the distance to our center point, the distance is the square root of whatever number's on top. In this case, 4. Which gives me the number 2. So my corner point is going to be 1, 2, spaces over. 1, 2, spaces over. And then you just draw your curve. And you're good to go. Your domain here is not all real numbers, and neither is the range, because remember, we have asymptotes, meaning x can't be this guy here, and the y can't be this horizontal asymptote. So the domain is all x's not equal to -2. And my range is all y's not equal to -1. Because we cannot equal those asymptotes. We can't get there. It's impossible. All right? Next one. Cubic functions. Cubic functions were a little bit tricky, you guys remember from your last one, where we talked about cube roots, and then we have those inverses. Just like cube root was shaped like that, cubics are shaped like that. So, we had a couple key points. Namely, we have this vertex here that goes left 2 and then down 1. We also know that we have our normal cubic shape that must be widened out to 1/4. So if we think about that, we know we have the point 2, 8 and -2, -8 on our graph. This will help us plot that out when we make our t-chart individually, or when we just think about what's going to happen when we use this 1/4. These are points on my parent graph. So on this graph, when we shifted these points over, left 2 and down 1, those would be here. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And then cut that distance by 1/4. So now that's only 2 vertical spots away. So now my graph looks like so. Domain, all real numbers. Range, also all real numbers. No stopping point. No gaps in between our cubic function. It's not a step function, okay? Final one. This one looks funny, but this is just a linear function. It's in standard form. Move some stuff around, solve for y. This goes back to Common Core 1 stuff right here. So, let's get rid of the 3x. Subtract 3x from both sides. Divide both sides by 2. 6 divided by 2 gives me 3. 3 divided by 2, that's -3/2 in front of that x is equal to y. So this form looks a little funny, but we know the number in front of the x, that's the slope, and this is my y-intercept. So I go up to 3, and I think, oh, well, that's negative 3 halves. That means my change in y is I'm going down 3, and I'm going right 2. Down 3, right 2, so on and so forth. You can also think of going up 3 and left 2. Now there's no stops, no gaps. Domain and range are both, again, all real numbers. All right, let's go on to these piecewise functions down at the bottom. The only thing that we needed to do here was figure out which one of these we're plugging into. This is my input. Input goes into one of these functions, one of these equations. You just need to figure out which one. So I look at this x value right here and I think, oh, well, is that x value less than negative 3? No. Is it between negative 3 and 4? Yeah, 3 is greater than negative 3, but it's less than 4. So I should plug it in right here. So we go 3 squared minus 4 is 9 minus 4, which is equal to 5. Now let's think of negative 6. We know negative 6 is less than negative 3, so that's 2 times negative 6 minus 7, negative 19. Okay? Similar process here. G of negative 5. This is now g of x. Negative 5 is less than 0, so I do the absolute value of negative 5 plus 2, which is equal to absolute value of negative 3. Final answer is 3. This one was the tricky one. You see g of 4 and f of 8. For here, you have to use both g, this second function, and f, this first function. Let's first evaluate g of 4. 4 is greater than or equal to 0, so I plug it into this function. So g of 4 is going to be negative 5 times 4 plus 2. Negative 5 times 4 is 20. Negative 20 plus 2, negative 18. Now let's find out what f of 8 is. F of 8, we have to go back to this function for. X is greater than 4, 8 is greater than 4. That's negative 3 times 8 plus 5. Negative 24 plus 5, which is negative 19. Now let's look at this guy. Negative 18 and negative 19. We are subtracting these two. I take these two outputs and I subtract them. Negative 18 minus negative 19. Subtracting a negative is adding a positive. Gives me 1 for my final answer. Okay? Now, for those of you guys who wanted to try out the bonus, this actually wasn't as bad compared to half the other graphs that were on here. Quadratic, we only gave you 2 transformations, a reflection and a shift left. And this one, we shift right and go down 4 for an absolute value. So first and foremost, let's think about what's going on with this quadratic. We go left 2, and we're just reflecting down. So graph that quadratic. I grafted the left side first and then reflected across to get the right side, which would give me a negative 1. Now I'm going to stop at that point just because I know my breaking point occurs at negative 1. So I started from my vertex and I started graphing on either side, but the second I got to negative 1, I stopped. I'm using a pen right now, as you can see, but for those of you guys who used a pencil, you could have graphed the whole thing and then just erased everything on the right side of negative 1, like so. Now, let's look at where this absolute value is going. We go right 2 and down 4. Right 2, down 1, 2, 3, 4. And we're here. That's the vertex of my absolute value. Remember, x minus h minus k gives vertex of hk. Absolute value, there's no slope going on, no stretches at all. And it's not a reflection either. This is a positive A value out front. It's positive 1. So I just extend a positive 1 slope on either side. Oh, hey, would you look at that? They meet at the same point. Negative 1, negative 1. So I don't have to worry about any open circles or closed circles either. They connect at that point right on my breaking point. And with that, we're done. So if you have any questions, feel free to post on Edmodo. Let me or Ruger or any of the other Common Core teachers know, and we will help you out. I hope that helps you guys too. Thanks.